Hello, fellow robot friends. I'm very excited about this new project called ElRobot. Sounds like Spanish or Mexican, from a company called NormaCore. And I've seen this on my tweet feed or X feed just yesterday. And I was looking into that and sounds very interesting as a project. So let me show you what the tweet was about here. So NormaCore is a company. There are probably two founders, and we can look into that later. I affordable, fully 3D printed robotic car, but actually is two arms, a leader and a follower. So a 7 plus 1 degree of freedom, so it's 7 joints and one gripper, like in Futurama. Idea for physical AI research, imitation learning, and zero custom hardware needed, so it's off the shelf and you can print it. Okay, so they provide everything, so steps, STL files, the assembly manual, ready to print Bambu Lab projects. Fortunately, I don't have a Bambu Lab. I'm going to buy that probably an A1 very soon, and URDF files. So I'm going to do a tutorial on that, but essentially these are like the equivalent of 3D files for robotic when you have to experiment with a model on a virtual environment. And okay, there's a link, but there is also a video. Let's watch this quickly just to get a feel for that. And I'm going to enable the audio. Okay, nice music. Cables. Looks like a trivial problem, but if you don't do it properly, they will be cut, especially when you have these roll joints, because as you roll, the cable twists and they snap. And this happened to me when I was working robotics many years ago. Not on industrial robots because they have rings to be able to essentially carry the power to these joints, but on these low-cost systems, it's very common to cut wires off. So it sounds trivial, but it's actually very hard to do that, to do them properly. Okay, there's a camera, lots of joints. There's definitely 7 joints. That's a bamboo printer. Okay, so supposedly you can print all the pieces. And okay, that's a 3 support. Motors, yes, that's a ST325, quite standard. Seems fairly easy to assemble. I guess there are also standard screws. And yeah, so that's the follower. Ooh, for code to matter. There is some also code. So there's a platform. And that person is essentially the leader arm. She's moving the leader arm. And those two are the followers arm, copying the same movement. This one is interesting. There's a bunch of things. I think she's controlling 2 arms. There's a WebSocket, some sort of FPS, so some sort of refresh rate. I can see a USB port, SCM0 and SCM1. I'm not sure. I'm supposing these 2 arms are connected to a box through the USB controller, and then they go online, maybe LAN or internet. And all these stats you can see here, lag, 30 milliseconds, probably is to show you that obviously, you need to have a very consistent lag to be able to replicate this motion in a fluid manner, right? Range is probably the angle, so I can see these integers are probably the PWM. ID is M1 to M8. Okay, it's just the 8 motors. So everything is it's a motor. It's so from 1 to 8, and the gripper is still a servo. But there's probably a gear that sort of extend or close the actual grip. Okay. Okay, it's picking up some objects. And obviously it's also important to, the gripper shape, but also the actual torque that you can apply because, well, there is the torque joint have a maximum peak peak torque, so the gripper needs to also be strong enough to be able to actually hold something, right? And we will see that later. Okay, spinning up an ice cube. You can get a drink with this. You can fold your clothes. I've seen so many demos with folding clothes. I guess people don't like folding clothes. Okay, spinning up something. Was that a spine? A bone from a salmon? I mean, if he's doing that with the remote arm, that's impressive. There's a camera, and there we go. That's a splash screen. Great. So, I mean, it's kind of like feels like a better version of robots. Essentially, we have more degree of freedoms, and so if you look at the original, well, the SO arm, which was developed by the Robot Studio in cooperation with Hugging Face, because robot is actually more about the data, not the hardware, right? So what robot is doing is mostly software, and Robot Studio has developed these arms. And let's watch this video. As you can see, it's similar, right? So you have the leader arm and the follower arm. They're also 3D printed. This is interesting. He's using this. Do you see his finger touching that? And this is really important. Like, you have to look at these details. Because if these motors on the leader arm are too, how can I say, they're too loose, the robot will collapse. But if you're too rigid, the problem is that you are applying too much force, and you have to do these things. If it becomes too stiff, it's really hard to move this thing, right? So this is something backdrivability, I think, is usually called. We used to have other terms in the past, but it's really important, right? So you see this guy is touching that, but you should really just use that, right? And so anyway, the original project, it looks like this. You can order now. Let's see for pricing, just to have an idea. Yeah, so if you want to add the, oh, it's out of stock. But if you want to add the, okay, so 3D printed parts is $35. It's provided by C Studio. It's a very well-established company. I actually know them very well from back in my days in China. But yeah, the price is around, like, let's say for the Motor Kit Pro, how much you're going to get for $260 without printed parts, right? And so for this, you get blah blah blah. What do you get for this? The ARM Pro Motor Kit. And what do you get? Let's see, just to have a quick view. You have the ARM Kit, ARM Kit Pro, ARM Kit, ARM Kit Pro, the follower arm, and the Pro arm. Okay, same videos as before. And let's check. So the difference is the leader arm, you have these two main versions. I know this is sort of out of date, so you should be buying this if you want to buy this. But you can see that in the ARM, let's talk about the ARM Kit Pro. You have all these joints, right? So you have you have one motor, two motors, three motors, right? So it's 3 plus 2 plus 1. It's actually 6, right? And the follower arm is the same as the SO ARM Pro, so there's no difference. Now, when you read 12, don't get confused. You actually have 6, right? Because you get 2 of them, right? So when you buy this kit, you have 6 and 6 is 12 motors. So you don't have 12 motors on one. And so yeah, so the Arm Kit Pro is actually, you know, for 6 arms, you have to, you know, you have to get this $260. So that's roughly the price. Let's see. I'm not sure if they're still selling the other ones. Let's see. Get one now. This is software. That's not interested. Yeah, okay. So if you want to buy the old version, the SOARM 100, the motor kit is around $200. Okay, and what do you get here? Plus March 12. Published before. And I think this one, where I see 12, you get two of them, right? So you get the leader and the follower for $200, which is pretty good, I would say, right? Yeah, you get two, but without the parts. And so, yeah, let's see the Pro version, how much it gets. 190. So yeah, you get a big difference in that. 100 AI, okay. So what they claim to be here is that you can do this for around, I saw the price somewhere, ElRobot for Lab. It's around $220 per arm. Okay, with about 14 hours of printing time, I guess it's on the Bambu Lab. So the price is kind of similar, but you get more degree of freedoms. Okay, right? So when you get 6, just to just sum up, you get 6 degree of freedom, but with this you get 7. And so where is the extra degree of freedom, you would ask, right? I'm really curious to look into that because from the video it was a bit confusing. So let's go inside just quickly. Go, that's a Go language. I'm not sure what is this, to be honest. There's no explanation about this. There is a Gremlin Go. Ah, okay. So this is high performance proto buffer for Go. Okay. Okay, so I guess this is what is moving those data points between the leader and the follower, but I won't go into this one for now. Hardware, let's see what they have. The gripper, yeah, this thing, okay. So you can see that there is, well, there's a gear and quite clever mechanism to, you know, to move them in parallel, okay. Okay, this is when he's getting something from the salmon. And that's the camera. I guess it's a Logitech. I'm not sure. And you get some sort of manual, which is very nice. So you get the gripper, camera mount, I'm guessing, and all the other parts. Okay, so that looks pretty good. Base, the gear, gripper jaw, gripper base shield, camera mount. And the servo is an ST3215, which is the same one as the ElRobot, I believe. Yes, the ElRobot have STS3215. So, what is concerning for me always with this build is these horns. The gripper gear, it looks like it's 3D printed, but over time that will definitely wear out, and you're going to lose precision and grip. So unfortunately, when you 3D print things, they get consumed. Okay, so the gripper, and then you actually have the actual robot. So you have two PDF. That's for the leader. So you have this kind of gun. Where with this trigger you control the gripper. Okay, so you have all the parts. Good luck, have fun. Okay. Servo horn, leader, what do you need? Yeah, it's pretty good. You have the gripper and the thing. It's like a cowboy gun, all sorts of screws. It doesn't mention what the screws are, but I'm guessing they're easy to find. Simulation, this is very important. So they have published an URDF, which is usually perfect for Isaac from NVIDIA. It's a little bit more difficult to use in Mujako, but all right, that's no big problem. They have all the STL files for every piece, and yeah, that's the gear, that's the jaw. So pretty well documented. So ST3215 are the actual servos, which is good to have, right? Because it's really important when you go into the simulator to actually know exactly where. I guess they just copy them, but my point is you really have to understand like these models should match, should reference the actual objects, which it does. Let me see here. Okay, so okay, they're properly named, and they seem to have also model. Yeah, there we go. That's the mesh name, which reference the actual object. So this is very well done. I really like that. I'm not sure what print is. Oh, FreeMF, I don't have. I'll show you this in the second part. Yeah, I don't have visualizer for that. Um, Images. Okay, we've seen these. STL. Oh, wow, there's quite a lot of that. Let's see, what do you have? The leader arm panel. So this is really for printing. Like if you want to print it in your, maybe you want to print it somewhere else. They are sort of clustered together here. And I'm not a big expert in 3D printing because I don't know if you want to put them like that or you want to print them one by one. And this is very important. So you can see how they separate the regular parts from the strong parts. And the point is that because this is made of plastic, PLA or PET, over time, as the plastic bends and deform, you're going to lose precision, right? And especially when you have a leader and a follower, you really have to make sure that they're identical. So if these pieces start to have some sort of distortion or bending, it's not good, right? Well, in the first place, you shouldn't use plastic. Ideally, you want to use something like metal with CNC manufacturing, but of course, it's cheaper, so I'm not going to really complain for that price. But something to consider is when you go and print these, make sure you follow the guidelines and you use, like the infill, very high infill values, and make sure that you sort of separate those parts. Okay, the individual parts. So yeah, this is all well done. So there is, all the funds that you need, the panels when you go and print them in bulk. I'm not sure what the case is. Oh, WaveShare. So WaveShare is probably the board, right? Because you have a servo driver board for this servo motors that you need to do that. And C Studio is probably another component from that. I need to see. Okay, so the 3D models are pretty good. And okay. Let's go for the print assemble. Okay, so they have everything. The weight is 800 grams, reach is 430 millimeters, which we'll see later. And this is the most important part, right? So you can see that you have the leader and the follower. So the follower is the one that actually needs to activate. So they have the ST3215 servo. Those are very popular, same as the ElRobot. Yeah, they cost $22. There is 8 of them. Okay, some discounts. But then on the leader, you don't need all that power because, well, you're just following, human arm. You don't have to lift anything. So they go for this 7.4 volt, which have a lower torque, and you need equally 8 of them, right? Okay, so the serial bus servo driver is this from WaveShare. I've used this before, and let's see if we can see it. And yeah, and as you can see, these are serially controlled servo drivers, which means that you can sort of daisy chain them. I'm not sure if people remember daisy chaining from back in the days, but if you look at this, you will notice that there are two ports. Well, it doesn't seem from the picture, but I don't know if you can see it here. But you have the, let's say, the input and the output, right? So you can put the cable in and the cable coming out. And this saves you cost on cabling because you don't have to have eight connectors here. You only have two, and you can have, like, let's say, a branch on the left and a branch on the right, or whatever. We can put that, and that there is USB. There is external power that you probably need in this case, and this is for the actual control. So this is pretty standard, and they of course tell you what kind of power supply unit you need. And what is this? Let me check. This is also pretty standard, so it's 12 volt 4 ampere, and they give you another one here for 5 volt, and it's the same thing. An active USB hub, that means that you need to have power in the hub. So that's another one, very important. Okay, and the camera module, yeah, that's interesting. I want to see what camera they're using, or they, okay, InnoMaker. And they have a table camera. What is a table? Oh, so it was a Logitech. So that's the one they're showing in the videos. It's a Logitech 720p. Okay, so it's not full HD, but it's only 12, 17. Yeah, I wonder why. Well, I guess you can upgrade to a full HD camera if you want to. Yeah, so they explain how this works. So active USB hub, external power hub is for the cameras. Okay, so that's for the camera. Yeah, because they get significant current. Driver board. Yeah, the driver board does not consume USB power for the motors. Yeah, this is just for the data because you have the the jack for that one. And the camera listed in the BOM are examples. Any standard UVC compatible. Yeah, makes sense. Okay, so now this is the interesting part. To ensure that the leader arm provides a natural feel, we utilize servos with lower gear reduction. So what they're using is 12147 or 12191. And if you look at the robot arms, they use different gears. Let me see if I can remember it. Yeah, so the follower, I'm kind of reading on the other page, but the actual follower arm is using 1 to 3, 4, 5 ratio. So this is definitely optimized for to having this kind of smooth feeling. So the follower arm uses also standard 30 kilo servos, which creates significant internal friction, making manual movement feel notchy. And the leader arm, lower ratio, allow for high back drivability. So yeah, it can move faster. The master arm with minimal resistance. So this was I was talking about from the other video. You have, with a lower ratio, you can feel less resistance, right? So you have, like, you can move this and it's kind of smooth. And so, as I mentioned before, yeah, the ratios are sort of higher for the 30 kilos. I'm looking at the leader arm for the SO101, and they use mixed ratios. So they use 1147, 1191, and 1345. So yeah, so I don't know if I can find the description again. Yeah, here we go. Here we go. So if you look at the the same versions, they have 6 joints, right? And they use 777 for the leader arm. Sorry, for the follower arm is the same as the SO arm. Okay. And Yes. Oh, so they do use, so ElRobot use 1, 2, 3, 4, 5 gear ratio for all joints. And they use the 12 motor versions. So they also use the ST3215, 3215. So what I can tell you is that indeed there is a difference, and they, in the follower arm, they are using different. Seems like I know. So in the leader arm, they provide actual field. Okay, so I need to find out the actual gear ratios. It's not very well explained. Yeah, for the leader arm. So my understanding is what they've improved, it's mostly the leader arm. Okay, this is where they talk about this lower ratio for more smoothness. And on the main one, it seems like they're using the same as ElRobot in terms of gear ratios. But fortunately, I can't. There is no information, and hopefully they can improve this documentation. So because I want to see a closer comparison, right? This is the panel for printing, and they do say that you should use. Okay, they suggest PLA and how many grams, so in total, does that consume, and how many hours. And then the Bambu Lab and Orca Slicer users. I should have installed that. Maybe I'll do that another support. Um, yeah, they only recommend PLA and AMS single nozzle. The AMS is that module for the Bamboo, and they do also provide this benchmark for the other type of PLA plus PETG supports. So that's very interesting. Yeah, so I believe this is true. So using PETG supports improves server finish, but doesn't really affect performance. Um, and well, this is the preprint checklist. Um, So okay, this is all very good. So yeah, there is the camera, so you can actually use different brackets for the camera, and the simulation contains the URDF. They do say that the Project Comer, the S100 robot are designed. Okay, so the handle, the trigger, and the restore are basically identical. Um, and the other thing I was doing was to look at their Discord, which I'm going to show you just now a few minutes ago. And, I was talking about those wires, and, well, was expected. So I think it's one of the founders' minor cable management update. Well, they after 3,000 recorded episodes, the cable began to wear out. To avoid excessive friction, we reduced the size of the panel. So, yeah, this I was right. So, like you can see here, I guess I okay. So before and after, what's happening here? Oh, I see what they've done. They moved the as you can see here. So the problem is when you move this, is probably touching them too often, but they have decreased the edge so that they're a little bit more free to move, and they haven't touched the other one. So very clever. So I like these details. So these details are really important, right? Um, the channel is okay. I mean, I guess I don't know how many people. There's okay. Wow, there's like 29 people plus 6 online. I have to say it was very quiet, like just in the days before. But now there seems to be some people talking about that, including myself. So yeah, feel free to join the Discord channel. It seems quite nice to talk with the actual founders. Um, and so yeah, okay, so I think this is kind of an overall. So let's go and actually see these 7 degrees of freedom. So there is one. So what's the main difference is there is one more degree of freedom, and the leader arm have a different gear ratios to have this kind of feeling of smoothness, right? So it should improve the quality of tracking. Um, And so let's go to my favorite robot viewer. This is developed by a person called, well, I don't know what's his real name, but Fun CG, Fun ZG Fund, probably, and it's open source. You can also do it on your machine or you can do it online. So what I'm going to do now, let's refresh this and let's take a look at this robot. So I'm going to take the ElRobot follower, the actual URDF, which magically should appear now. And we don't see anything, so it's loaded, but you need to put the initial property. So I think that's the arm. I can, well, it's all cubes, guys, because, well, if you look at the digital visualizer, it's, okay, no, it's referencing these meshes. And, well, one thing I realized now with this type of visualization is not going to visualize those meshes, of course, because well, let me try to actually do something. Well, I don't have the folders. Let's just look at the joints for now, and then I'll see if I can visualize the entire thing. Okay, I'm going to show the inertia. So this is the center of mass. I don't care about that. Let's look at the joint axis. And so you can count. I did something stupid, sorry. You can count, well, there are 8. So this is 1, 2, let's see. So it's like 1, 2, 3, 4, 5, 6, 7, because that's going there, and another 8. So it's really 8. Let's go for degree. And so what do we have? We have rev motor 1, 2, 3, 4, 5 until 8, and then is 8, 8, 1, and 8, 2. I'm not sure what's that about, but I guess it's the gripper. So rev motor 1, I guess is the shoulder, usually. And yes, it is. So you can see it's moving along the zeta axis. Okay. And it's going to move between 90 and minus 90. That's what in terms of degree. Okay, so it's doing that. Then we have the second motor, which is moving, let's say, the yaw, right? So that will be sort of, again, part of your shoulder, right? So it's going up and down. Yeah, I'm breaking this. Okay. Let's reset it. Motor number 3 is what? Sort of like, I will call that the elbow, although it's very short compared to the, let's say, the upper arm. But okay, that could be the elbow. I'm not sure. How would you call that? But then you have another one there, which is interesting. It's like a 2 degree of freedom elbow, I think. That's how I would call it. Because you can move that, but also you can move that. That's pretty interesting. I'm really curious to see why they're done that way. Then we have number 5. So what is the joint number 5? That sounds like you would think it's the wrist, but once again, I think it's to simulate the actual forearm, because your forearm, you can also rotate it, right? So I can rotate my wrist, but I can also rotate to some extent, my forearm. So that's pretty cool. And yeah, you get 170-degree each way. Let's reset it. And we have, what is this? So this is kind of like the wrist of your hand, right? And you can go 90-degree either way. Okay. Then you have the rotation of your wrist. Okay, so you can go like 170-degree either way. And motor 8, I don't know, it's rotating, nothing is happening. I think this is meant to be the actual Oh, this could be actually the gear that spin, right? And so you can go under 80 degree to open and close the actual gripper. But of course, I think these two blocks are actually what is the gripper, so you can move them uh, sort of in antithesis because they are connected to the same gear. So like they will go like that, and that will go like that. I obviously they're not going to collapse to each other. So yeah, it's really a degree of freedom. I like this idea, and yeah, it looks well. I mean, it's sort of more realistic in a way, more bio-inspired to a human arm. So let's now load the SOR 101 just for to show the difference. And I'm going to load the 101 new calibration URDF. I think this was the most accurate model they've released from. I found that from this portal, so you can go here and file the URDF files and all the specs. And so let me go back to that. Okay, let's put the inertial gain. Yeah, it looks like that. Sorry. And we have one. Okay, I like this. This is a little bit more clear from the robot. I think it's kind of more intuitive. So you have the gripper. So let's start. And the shoulder pan. This is the shoulder once again. So let me go to degrees. Reset. So it's 110. So I think there is a little bit more limit here. The shoulder lifts. Okay, so you can go up and down. The elbow flex, so you get only one on the elbow. There we go. And then you have the wrist, so you have the kind of I guess the yaw and or well, whatever you want to call it, to the degree of freedoms, but you have essentially what they call the flex and the rotation or the roll, yeah. And then you have the actual gripper, which is again, it's once again, it's probably the same thing, right? So you kind of do it. It looks like it's a finger, but it's actually the rod, I guess the gear moving. So yeah, so that's the big difference. So this is you have the hand, let's say the hand, and you have the two on the wrist, one on the elbow, and two on the shoulders, but the other one has actually an additional, the ElRobot has an additional degree of freedom to, well, actually, there's a major differences. So they have the same, let's say, shoulder movement, but they have two here, and there's an additional, let's say, detail. So the elbow can have two movements, but also kind of a rotation of the upper arm. So yeah, I get that. So it makes sense, and I guess that's why obviously you pay a little bit more because you have more degree of freedoms, but and I guess the weight is the overall. I'm not sure what's the weight of this. We'll have to look into that. And the software, I'm not sure about the software, so I think in the next video I'm going to talk more about the software. If there is anything published, I'm not so sure. And I will probably start to build one. I don't know how long it will take me. I need to probably print it online. And yeah, this is pretty interesting. And I think it would be nice to have them back to back at some point to kind of show the difference between them. And the software looks also very interesting because I want to see the latency throughput. Well, the throughput you don't really care. It's the latency and how good is their software to give you this feeling of latency. So like you have to have very low latency across probably an unreliable network. And yeah, I'm just curious to see that. So I would say overall, I like this project. It's very well documented. The cost is reasonable. They're giving back something to the robot with their gripper, and obviously they reference the the project, and yeah, there's some innovation on the on the configuration. So yeah, it's a great project, and yeah, I will do definitely another tutorial or another video. And so in the meanwhile, if you like my video, remember to like and subscribe. So see you very soon, and have a nice evening, folks.